So, good afternoon, everyone, or good evening, or good morning, depending on where in the world you're joining us from. I'm Jarka Glassey, and I'm the president of the European Federation of Chemical Engineering, EFCE. I've taken on the role of the president this January 2026, following 2 terms on the board of EFCE as the vice president executive. I'm actually a biochemical engineer by training, and I graduated from the Slovak Technical University in Bratislava in Slovakia, but I worked all my professional life as a professor at Newcastle University in the UK and recently took an early retirement from there so that I can spend more time engaging with other universities around the world. I'm really happy to be involved in the introduction of this webinar on ethics in chemical engineering education. As those of you who know me know, I'm really passionate about the education of chemical engineers and consider ethics to be an absolutely essential integral part of chemical engineering education. Normally, I say I'm really looking forward to participating in the webinar, but unfortunately this time around I will have to return back to my other duty, which today means accreditation. So I will have to just wait and see the recordings, I'm afraid, but I'm sure you'll have a lovely webinar. But first, let me say a few things about Spotlight Talk series. So this is now our 6th year of the Spotlight Talk initiative, which started in 2020 to keep together the community during the COVID pandemic. The success of the previous years convinced us to transform the spotlights into a regular feature of our program. So we now have 1 spotlight series talks in odd years and 2 in even years, like 2026. So this spring, 11 of our working parties and sections are delivering over these 2 weeks 9 webinars of 3 to 4 talks focused on specific topics by leading industrial and academic experts. The series also enables attendees to sample matters in new areas, encouraging cross-fertilization of interests. The complete program is available on EFCE website, and as I mentioned, you can actually view the recordings on our YouTube channel. EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries, representing more than 100,000 chemical engineers in Europe. Our working parties and sections cover all major specific aspects of chemical engineering and are in fact the core of the organization, forming the scientific engine that drives many of our activities. They provide an important forum for technical exchange and networking among chemical engineers in Europe. And I'm pleased to announce, if you haven't heard yet, that this year EFC introduced a new initiative, virtual coffee meetings with the president, so that we can discuss over, unfortunately, just a virtual cup of coffee, the ways how we can strengthen our collaborations with colleagues. These coffee meetings usually take place every 3rd Thursday of the month, with some of them dedicated to member society representatives, and those would have received emails notifying them which those are on. But other sessions are open to anyone who engages with EFCE, and for those sessions you can find links on our website. So please do register and pop in for a virtual cup of coffee so that we can hear your ideas of how to make EFCE even stronger than it is. But before concluding, I would like to thank all the colleagues who worked hard within the working parties, sections and wider EFCE for this initiative to happen and to be successful. In particular, many thanks to EFCE's Martin Pou in Toulouse. Again, thank you so much, Martin, because you did most of the conceptual setting up and practical activities for all of these series. And thank you for your attention, and I wish all the speakers and the attendees a fruitful and successful webinar. And now I would just like to give back the word to Professor Edith Sekei, Vice Chair of the Working Party on Education, who will take us through the start of the webinar. Edith, the floor is yours.
Thank you, Jarka, and thank you for the introduction. And before we start with our exciting talks we planned for today, I would like to spend a few minutes on introducing you the Working Party of Education. Actually, the Working Party of Education, this is one of the working parties of the EFCE, and is chaired by Herman Joseph. And our mission is to promote good practice in education, especially nowadays in digitalization and ethics. And this spotlight talk is about ethics. Promote continuous professional development within conferences, but also with supporting with teaching materials, methodology, help, and so on, and also to influence policy. And if you haven't visited that, I recommend you to have a look on the EU Bologna process and Bologna recommendation, which was developed by the Working Party and approved by the EFCE. And also we try to promote the STEM education all over Europe. In the map, the blue are the countries where we have representatives from. If you see your country missing and you would be happy to join us, then please just apply and we would be happy to welcome you. And in the Bologna process, we made the Bologna recommendations originally in 2010, and then it was updated in 2020. And this is a descriptive document describing credits and different systems in Europe, and also recommendations for the learning outcomes, and also some of the teaching methodologies. It was relatively big work and also includes lifelong learning and communication and other soft skills, or I would say transversal skills, recommendation for all levels of chemical engineering education. Additionally to this formal document, the Working Party is very active in promoting various fields of chemical engineering education. I would just like to mention the particle technology videos, which is just under development, to spread the word how exciting chemical engineering is. Spotlight, one of this event is we are just right now here. The Student Mobility Award is also promoted by the Working Party of Education, and it's typically for a conference, a big conference, for those students who are very active in mobility and who understand that mobility just helps their careers. And these modern teaching methodologies is a type of directory, I would say, where you can find great ideas about active learning and how to develop a course with active learning. And before I give the word to our speakers, I would like to ask the participants to share their questions in the chat. So you are not, you cannot join with voice to the meeting because of the recording and the large number of participants typically present in the spotlight talk. But please add your questions in the chat. And after the presentations and the talks, after each talk, we have some time for questions and answers, and I will read out the questions. And if some question remained unanswered, then we can also answer in the chat or come back to your question at the end of the session, because we still have some time at the end scheduled for discussions. And as we are arriving to the starting time of the first presentation, I would like to ask our first speaker, Alessando Bettoni from Technip Energy, so from industry, to share his views on ethics education and chemical engineering. Alessando, the floor is yours.
So good afternoon, good morning, good evening to everybody. I hope I can be heard clearly.
Yes.
Great. And so just to start, okay, I'm one of the members, industrial members of the Working Party on Education, and working in Technip Energies as a engineering contractor in the field of energies, spreading from oil and gas to energy transition and the like. So just to start the conversation today, when we talk about ethics, I think it's clear to everybody what an unethical behavior is. And it's always easy to frame the ethics by understanding what is not ethical. And I think we have, unfortunately, a lot of example today also from some governments of what unethical behavior means. But what we will try and do, and what we have been trying to do, is give a definition of what is ethical and what it means, and highlight. And what I will do is showing it from the perspective of the industry, how this actually happens in the everyday work, how this is a lot about decisions, about understanding and managing risks. It's also about a cogitative approach, so slow versus taking shortcuts, and then we'll just go through and compare how this is working out in university and work, and then we can see there's a lot of similarities in comparing the two environments of university and industry. And just to conclude, also just a quick note about the fact that the way we define behaviors and ethical behaviors is changing all the time, so we need to handle that. And just to close, I will just highlight a few case studies and also conclude to send a few messages about how we can work to introduce some of these core concepts into a curriculum in university courses. So, but going through and trying to go beyond saying what we are not and what we do not want, let's try with first of all giving an understanding of a perception of our view of what ethical behavior is. So just edit to confirm you can hear okay?
Yes, everything is fine.
Great. Okay, great. So basically, ethical behavior is about its core. It's about decision making and about prioritizing during the decision making. First of all, the protection of all stakeholders. We've mentioned here society, the environment, and our colleagues. It is about following, enforcing rules, laws, and standards. And that means, of course, first of all, understanding well what those rules, laws, and standards are. And this, of course, is a key task of university to help understand this. It's also about communication and collaboration, but this communication and collaboration must be open, and it must be to be open, be free from any bias and discrimination, to be an effective communication and collaboration. It is also about accepting responsibility. That means ownership of our work. And another topic which is especially very sensitive today, it is about handling information and data. And this is, let's say, reflecting also in being sensitive to one's own work, but also to other people's work. And today, more than any time, the importance of managing confidential information, avoiding plagiarism is a key feature of how we should work in an ethical manner. And then, of course, it is also about acknowledging that our knowledge is limited. Our knowledge also needs to be developed and adapted to what is happening around us. So always being aware of the gaps and always being open to an attitude which is of continuous learning. So basically, to summarize, it's all about taking decisions and living up to the consequences of our decision. So this means, rather than just thinking the world and our way and our behavior in terms of abstract rules, it's about favoring a risk-based approach. So every time weighing and measuring risks to understand and try and understand the consequences. It is also about living in a context of uncertainty and understanding and perceiving this uncertainty. So again, doubt is not an issue. Doubt is really a core element, a core value that helps us in our decision-making process, because it is appreciation of what we are lacking and what we are missing. So when we try and map our world, just as the explorers did when the new continent was reached hundreds of years ago, I mean, the right approach is don't try and create, rather leave empty spaces in your map so that you know that's the limit of your knowledge. So you know the contours, you know the limits, and that's what you know. Don't try and put things you don't know. And of course, acknowledging that in any case, it is not possible to avoid taking decisions. This is true in a work environment, in industry. It is true also in a learning context of a university. I mean, this is the same path even a student in a learning process will go always through, taking everyday's decisions and facing the consequences of their decision, be they good, bad, if ever we are able to define what or assess what is a good or a bad decision. So what we want to aim to do is and understand how university can prepare us to take those decisions. And to get there, we go through first delve a bit more into the what we mean by the risk-based approach, working in the uncertainty and the slow thinking and the like. So first of all, a risk-based approach means, first of all, knowing. So knowing what we know and understanding the limits of our knowledge. So that means in practical life, looking carefully at inputs, at all the data that are available and the way we map that data. Also understanding properly the requirements, what is expected from us. And also, once we know the requirements, understand and set what are the priorities and the needs. And then to frame and start our work, we need to be on a common page about a common understanding. That means having a proper glossary of terms and knowing what are our sources of truth versus what are assumptions. And this is a key aspect of working in the industry that and that was just so many times we get it wrong. It's having a common understanding of words and having a common understanding of what is a source of truth, I would say more functional truth, and what are assumptions that need to be tested is of uttermost importance. All these make up what we typically call in a context as integrity. I mean, integrity is really understanding and having a proper perception of the data and the underlying information that we handle. It is also about understanding who are the stakeholders involved and what kind of impact we have on them. And here, important to stress when we handle stakeholders, there is no such thing as a zero-sum game. This is this is not what some of our governments are telling us, but this is not the way an interaction works. An interaction is always looking at one's own benefits and the benefits of the counterpart. A transactional approach brings us nowhere. It's about weighing and measuring. It's not easy to do, but that's something we always have to do in once we've understood and classified the data. We need to weigh every time. We need to weigh our progress in terms of number. We need to weigh the resources and the way we are using it. We need to weigh also our priorities, and we have to set priorities once against others, understanding what are sacred cows that are really on principles we cannot touch, and what is not an untouchable principle and then has to be measured against other sets of priorities. And then it's about communicating with all the stakeholders, and here we are facing an initial dilemma, and ethics is a lot about dilemmas. Is a dilemma about, of course, in a open non-transactional approach, we want to be as transparent as possible and not being withholding information. However, we always have to keep in mind all the stakeholders, so ensuring that any intellectual property is being managed correctly, so not divulge if not in appropriate manner, and of course understanding in a competition, a competitive environment, that the sharing of information is also subject to what may be the needs of the corporation, the company, or the context, or the association we are working for. And again, in a risk-based approach, it's normal to fail. We fail every time, but really part of the process, it is normal to fail, but we really have to learn from our lessons. It's normal to fail. It's not normal not to learn from the failures. If we pretend they do not exist, if we pretend we are always the winners, that defeat is not in our panorama, we will learn nothing. So again, another checkpoint with the edit. The sound is okay.
Yes, perfect.
Okay, great. And so looking at companies, and sometimes this is what a lot of newcomers feel when they start working, is they feel there's a lot of bureaucracy slow. But let's consider this bureaucracy, this complexity is sometimes coming to help. The way big companies work with their procedures and their steps, it's also to facilitate a slow cogitative approach to problem solving versus a fast one, which can have advantages in some context, maybe say more a startup environment, but also brings a lot of risks. So especially when fast means taking shortcuts, which can mean being not fully aware of the consequences. So there's a lot of talk about company culture. That means, company culture is a set of history of the way things are being done and the people that belong to that community. So it's favoring an incremental approach rather than a disruptive approach. But this helps in assessing that whatever we do in what we would call an ethical manner. So it's a lot about the process. The outcome, of course, is vital importance, but let's stick as much as possible to the process. That sometimes sounds a bit like rituals, like we are kind of going through a set of rituals, our gateway meetings, our jargon, and it is definitely from newcomers. It is always a mystery, kind of some mystery rituals, but there is something to it that is part of the culture, which is really about ensuring that whatever we do, we do it in a frame of a culture and values, and looking for an approach which is searching for consensus, again, maintaining in the keeping in a context of a company culture. And this is reflected in what companies always have. Every company has a code of conduct, but as much as it might be perceived as something that is quite obvious and common to all, I can tell you codes of conduct are being updated continuously. So we should never take code of conduct for granted. So it's always good practice reading the code of conduct for companies. And again, it might seem obvious, there's always something in that is unique, but also it's about the way the companies approach their own work processes. So it's again, we tend to, or we like to look at the big picture and simplify it, but we always have to perceive the big picture is made of a lot of little stones and parts. So we cannot have just the arch and the bridge if we don't have all the stones. Without the stones, there is no arch, there is no bridge. So this is how we see it from the point of view of industry, but I think, if you look at it from the point of view of academia, there would not be that much of a surprise, because a lot of what is encouraged is the same kind of approach that is being encouraged also in an academic context. I mean, just think the attention to the process, also in the examinations and the tests. I think this is something that is really core part, and it's good. It's about getting people to also to learn in an ethical manner. It's also about understanding uncertainty. So, as we already said, acknowledging one's gaps. And this means, again, learning to say, I don't know. And also trying not to assume we know what's best, or assume we can calculate what's best. I think a lot of us have come across, especially with let's say the big tech, in the world of the big tech and the AI companies, there's a lot of talk about this effective altruism. So the let's say an approach which is trying to measure as much as possible the altruism in terms of, or the action in terms of really measurable outcomes, comparing and trying to work out solving dilemmas as mathematical formulas. It's important, useful. However, we have to have a lot of caution about this approach, because it's every time we are trying to work out what's best, we are talking about the lives of other people. So we may not have all the understanding and the elements to understand what's best with other people. And this is always important to know. Obviously, no, not acknowledging we don't know means we always have to be ready to learn from our mistakes, but also being open to let's say, to a continuous learning approach. And what was in working in let's say, thinking in let's say a Bayesian approach as we have in statistics, there's what we call priors. So a Bayesian approach is a step-step trial, let's say, kind of trial and error approximation of a statistical problem, which is based on having a starting point, having a prior point, having a basic knowledge, being able to have the very basic back of the envelope calculation does help us when we approach sophisticated models, sophisticated context. Having that basic knowledge can give us a slight perception in a context of wide uncertainty. And uncertainty is also about dealing with people, and with dealing with people, we have to be humble. We always have to assume it's not sufficient to just tell people. So the humbleness of following up, which is it's not just about assigning tasks, it's about making sure that other people understand what they've been asked for, making sure that they are carrying on, is not assuming all the time. So if we go back to university, all this translates into a lot of what we find in a lot of the courses, and this is what I guess would be important to insist on in any lecture. So again, relying on modules and software, but having the sensibility to the back of the envelope calculation is always important. The practicing knowledge through a trial and error approach, and this is how it is often done in labs and experiments, so on, is a key way of getting into that handling uncertainty, risk-based approach. Have that basic knowledge that makes us understand, even understand an experiment and what we are to expect. Having tools to assess the robustness of our solutions, so being able to analyze the sensitivity of our reports, thinking long term, so having the ability and the tools for a life cycle analysis of any kind of solution, and not having shortcuts, but I mean, and again, being very careful about the so-called hallucinations. This is, hallucination has become the very popular word associated with artificial intelligence, and this is exactly is assuming we know and we can say something when we don't have the exact background of the information. This is exactly what some LLM tools do, and this is what we have to avoid. And even when we use such tools, we have to make sure that does not happen. So, if we look at ethics, from university and industry, and I won't go into the details, but we can see we look at a set of keywords, and basically there's a lot in common. I just would like to highlight one part, the concept of the brand. This brand is always associated with let's say advertising world and so on. I just want to recall what brand means. Brand is associated with the branding, the livestock, the cattle. This is and the same word brand in German, marchio, in Italian. So actually, brand is something that once it's there, it's unchangeable. So contrary to what is the perception, a brand is something that is something there to stay. It's really about a long-term reputation of a company. And when you really talk to marketing people, you come to understand that there is. It's not like you can suddenly switch for advertising and giving a completely different image of a company. Marketing does not work. Marketing is a long-term approach. And really, whatever we do, it stays there. We cannot change it with, let's say, a fancy ad. So as we said, ethics is a bit of a moving window. There's evolving social norms, also some generational factors. There are new frontiers like the approach to LLM, large learning language modules, which is really a game changer in the way we handle and manage problems today. So a lot more to harness. There's also a lot about new communication and new styles, and what we were used to before about things we say, things that are written down. With all the new social media is much more blurry, and people using written media as if it were speaking, and vice versa. So and because communication is a key part of how we handle stakeholders is a key part of how we manage risks. Risks is a key part of how we behave ethically. So let's keep in mind how this change in communication style is key and important for us. And these the what are the existing frontiers are being stretched, and we see what we have seen in these months how things that approaches that would have been considered unbelievable from our from governments or today becoming a standard approach, and we need to face and be understand that. And to handle these changes, we have to continuously scan the environment, assess the gaps, engage and agree on let's say a common understanding of the situation, and continuously redefine, update policies and tools and methods, and go in this continuous learning life cycle. So, mindless of time, there's a lot of cases where where ethics and dilemmas come into picture. I mean, safety of security is putting at risk the lives of others. This is exactly what we are facing today. Having work sites in countries that are facing, or countries at war, countries that are at risk of being hit by missiles, by drones, and having to make tough decisions about, I mean, first of all, the priority is the lives of people who are working in the sites. It's also about managing externalities. I mean, the environmental impact, carbon footprint is a key topic today. In reporting, and this is financial reporting, but it's also technical reporting, the need to always adhere to truth. That we can tell stories, but we cannot make up truth, and we cannot change facts. Data handling, respecting the works of other, respecting other people because it's intellectual property, but it's also data. Managing stakeholders, dealing with local communities, and apparently it might seem easy, but it's always facing dilemmas because dealing with local communities sometimes also means dealing with local governmental entities. Dealing with the governmental entities means engaging into a domain where the interest at stake may be different from the local community, and there's always risk that we have to very well keep in mind. Collaboration, as we said again, avoiding a transactional approach, and of course we are companies. We work in a competitive environment, but we making sure that we compete fairly and on merit. So no cheating, just as in university, no cheating. We have to compete for a good result on our own merit. So to conclude, what, let's say, are areas of focus? The importance of knowledge, so understanding what we know and knowing our priors, understanding the context, the rules, laws, standards. This is vital importance. Focus on the process. So again, it's important to show how we get to a solution, and really to make people understand, should avoid shortcuts, and especially be very wary about the risk of hallucinations. It's ethics, as we said, it's about taking a decision. So how can we manage, and how can we help people on that? It's about handling uncertainty. So always being mindful about the sensitivity of the outcome of any work, and it's especially about risk management. So risk management is probably as always a good topic to be part of a good curriculum for a chemical engineer from our point of view. And ethics is about stakeholders. So again, in an academic environment, it's about teamwork, and it's about understanding the consequences that our action has on the stakeholders, so our externalities. So thank you. Sorry, I might have run a few minutes over time, but open to questions.
Thank you so much. It was really exciting. Yes, we are a little bit over time, and we right now have no questions in the Q&A part. So I would like to encourage the audience to type their questions. And meanwhile, I'm sorry, even if we have no time, I must ask one single question, because that's what you talked about is that it takes time to be correct and understand the consequences. But also when we are talking with industry people, that's always a demand that people are on time and project finish on time. So it's a requirement of finishing the projects in time and giving the answer in time and being good in giving the answer. How can you balance it in practice?
Yeah, I mean, I think we always have to realize we are working in a time-bound context, and this is really about how we manage projects and activities. However, I mean, at least from in a company, in a corporation environment, there is no way we can bypass the what or all the required steps. So I mean, there is a focus on this gateway meetings, whatever we do, even if it's if it's we have 6 months, we have 1 month, we have 1 week, we cannot bypass the gateways, the steps. A stepwise approach is what really helps corporations make sure that, okay, maybe we have to accelerate that, but there is no this is part of golden rule. This is really something that cannot be accepted. We can shorten time, we cannot jump the steps. This is the only safeguard we have. Is yes, we are mindful of time, but mindful of time means sometimes that means also asking people, yes, that's you've got a week, but you have to sit down, prepare the slides for the gateway meeting. And so it's annoying, I have only 1 week, but you have to do it, because we have to make sure that every point of that step we did what we had to do, and we are not opening to risks and facing the consequences. So I think that's the only safeguard we have, is just always thinking about the process. We squeeze the time, but the process is there and we have to keep it.
So the bureaucracy makes sense.
Bureaucracy is perceived as a bad word, but I say bureaucracy does make sense.
Okay, thank you, Alessando. I'm sorry, we really have no time for further questions. So I give the floor to Kseniya Papchenko, and she's from the early career chemical engineers, and from the experience, wisdom of industry people, we are just turning to the voice of the young people. So the floor is yours.
Thank you, Edith, for your nice presentation, and thank you again for the invite. It was really fun to prepare for this presentation. I'm gonna share my slides. I hope you can hear me well and see the screen.
Yes.
Thank you. Okay, so yes, hello everyone, I'm Kseniya, and as Edith said, I'm also happen to be a vice chair of the early career section of EFCE. So the presentation from my side today is about the early career and how we perceive ethics in everyday life. So how does this affect our choices and our views? I would like to start with a bit of a personal example. and specifically what kind of ethical issues can we see in the chemical engineering profession, right? And the first time I encountered this, one of the issues that was explicitly framed as such was the Space Shuttle Challenger disaster in 1986. And basically, the whole point here was that there was an engineering issue, which is the failure of an O-ring that brought an explosion and killed several people. But it was basically about the normal behavior of a material that today we know, but at the time it was underestimated. And this engineering issue brought an actual ethical issue, let's say, which is very well expressed in this article for whoever is more interested to read about this disaster. And basically, it's about this duality of how people perceive themselves once they are part of a bigger organization. So it's this sort of belief that as individuals, we can be feeling as powerless, and our choices and our opinions stop to matter at the bigger scale. And the interesting thing about this issue in particular for me is where I was when I first encountered this specific problem. And just a little bit of a background, the point is I was formed as a chemical engineer in Italy quite some years ago, and then I spent my PhD between Italy and UK. After I finished, I decided to give back to the community, hence I became part of the early career section, and today I am a postdoc in France. And while this is quite several years of education, the first time I encountered the problem explicitly framed about ethics was actually when I was teaching. And I was teaching a course on materials, and hence this was one of the final parts of the course, where we were able to discuss of how a decision can affect in potentially unpredictable ways what is going to happen, not just to a company, like to people, but also to a company and also to the national vision of something. In this case, this was about NASA. And of course, I'm talking about explicitly framed problems because I was able to see other problems, for example, the incident of Seveso during my education in Bologna. But there is a distinction between presenting a problem as something we can learn from and something where we can actually think and contribute and discuss about. So after this, I started wondering, what are we talking about when we are talking about ethics in chemical engineering? What is it all about? And then if you look at how chemical engineering is defined as a profession, for example, here I'm reporting the definition from EFCE and from EFCE. I hope I pronounce EFCE well, actually. I'm never sure. And it's, in summary, it's all about the knowledge and the skills that we learn and that we have to apply to develop society, to benefit the profession, to create sustainable outcomes, right? So it's all about us doing something with what we learn, right? But then when I read this, sometimes my personal impression is about this, applied with judgment. And my first thought is judgment, like me? How I'm not qualified to give my personal judgment to this, even though I'm formed as a chemical engineer. And this is basically, this is coming from the way that sometimes ethical problems are presented during education, which is about, again, learning, but not necessarily discussing. So we take opinions from other people, but we don't have an option to discuss these opinions ourselves. And also, why am I supposed to learn about ethics at all? I mean, I'm gonna have so much time to think about it later, right? And then, for example, if you look at the Royal Academy of Engineering definition of ethics, they published recently, well, they updated, sorry, very recently the statement of ethical principles for the engineering professional. And this is not specifically to chemical engineering, this is in general to engineering. And once again, when we look through it, it's very interesting, it's very powerful, and it basically consists of several principles like honesty, integrity, responsibility to society, accuracy, rigor, leadership, communication, and also responsibility for the future, which is very powerful, very strong definition. And in all of this, the engineer is seen as someone who has a duty to do something. And while I totally agree with all these principles, in my mind, as someone who relatively recently finished being a student, I cannot help but ask myself, aren't we maybe expecting too much from students or early career professionals? Because usually we all have personal values, but how do these personal values align with job security in our market? And whenever I'm part of the organization, once again, is it my responsibility to uphold these principles, or is it an organizational responsibility? But also, what happens if I'm working with other countries? For example, during academical collaborations, not everyone has the same standards. So how do we make sure that all of this is uniform? And again, is it really up to me in this case? And sometimes, honestly, ethics feels like luxury. Which of course it should not be a luxury, but sometimes it can feel like such. So then it's not just about having a duty to do something, but it is also avoiding being isolated in these choices and understanding that it's never too late to think about ethics, of course, but also sometimes there's just no time to think when you're a student. But finally, how much effort is expected from each individual? So these are the questions that I have and that are in a way shared with other younger people, let's say, with other early careers. And at that point, I try to answer through, for example, education, right? So I understand why it is important to learn about ethics, but how do I learn? Where do I learn? And let's assume that I want to learn during my education as a chemical engineer. And here it's where the accreditation comes into the play, right? And again, I'm just citing something here. And for example, as one of the countries I've been in, UK, the ethical curricular started appearing in the last decade. This was relative to 2013, so we're talking about 20 years now. Which basically means that a lot of us, not just me, were not taught ethics at all. We're not presented with ethics at all. But let's assume that the new generation has, of course, better possibilities to encounter this in their studies. And from my understanding of the whole system of accreditation that can give you a bit more security, let's say, of what you're going to study and how you're going to be formed. But then there's two main routes, right? We can have a module on ethics, we can have, so basically you have all your core disciplines, which are insanely important, of course, and then you have a module that connects these core disciplines to the real life, let's say, real practices, or we can have embedded ethics. So this was the case for me when I was teaching the course on materials. So there is a time dedicated during the course to a specific question, where the students are invited to interact and to think. But then, once again, it's about who should teach this, when they should teach this, and where in the curriculum. And from my perspective, as someone who finished their studies not that long ago, it's also about making this engaging and relevant. It's about making students understand why is this important, because there's no doubt it is. However, when you're a student, I feel like most of our attention goes on to passing the exam, rather than understanding the ethical implications of our future profession. So it's an incredibly important job to do this. And another thing, there are only a certain number of hours that can be dedicated to the teaching in general. So how do we maintain the quality of what we are teaching while reducing, let's say, or limiting the quantity? But okay, let's assume that I am convinced I want to study the chemical engineering somewhere. I believe that accredited courses are the best choice. What are the accredited courses? Who does the accreditation? And now I've done a little bit of checks, let's say, and there is the Accreditation Board of Engineering and Technology in US, for example, that does accreditation not specific to chemical engineering, but to engineering in general. And then there is, of course, in Europe, the EFCE. And what is interesting, just a small note, it's that the accreditation is does not give confidence to the potential student about the quality of their education, but it's also about confidence given by the accredited course to employers, which is more and more requested. And also, just a note, accreditation basically gives an idea of what is going to be taught. And well, yes, of course, it's also about the quality. A lot of courses that are of extremely high quality are still not accredited, and this is because this is just a relatively new thing. And at this point, if I do want to study at an accredited course, where do I go? I look at the countries that where courses have been accredited by, for example, these two entities. And this is the general picture. And basically, there is not that much choice, which is quite interesting, of course, because again, it's all work in progress, and there will be more and more countries. I'm very sure that in 10 years, this picture will be much, much more colorful. But at this moment, there is not that much choice. And in particular, EFCE is mostly concentrated in UK, and ABET is mostly concentrated in US, as it is fair. So they are growing, they're trying their best, of course, as Jarka said herself at the start of this presentation, but there is still a long way to go. And this is one of the ways to be sure that there is ethics embedded in our curriculum, but of course we have to think what happens if this is not explicitly stated. And I feel like a lot of people from my generation kind of missed the train of having ethics during their course. So what do I do if I finished my education, but today I still want to learn about ethics? And at this point, my personal suggestion is finding resources, thinking, discussing as much as possible with other people, both chemical engineers and not chemical engineers, and then do this on repeat, because that's the only way we learn things. And the best place, well, one of the best places to start is the EFCE website, actually, because there was an ethics series not that long ago, that gives you an idea of ethics applied to chemical engineering, but also about education to ethics. So this is a first way to start thinking about it, to start seeing what's out there, because usually it's not about not having an idea, it's just because no one really told us to consider something like this. And on top of this, there are other things, for example, like ethics, engineering ethics toolkit, and this is useful for both teachers and students, because again, most of us, like I'm talking from the perspective of a student, right? And again, it just gives us an idea of what I learn can actually impact what I do in my profession. And then finally, if you are not that much into reading, you can look for a course on Coursera, which this specific course, I'm not sure if it's free actually, but it is based on a book that is accessible. So there are a lot of resources that are becoming more and more accessible. So now the point is about nudging, is about giving that thought and placing it into the mind of younger people, students, so that we students and early career who are looking for their next job, for example, to think about the repercussion of the choices and to have an idea of what these repercussions can be. And finally, what about today? And when I'm talking about today, unfortunately, I'm talking not just about uncertainty in terms of job, in terms of where we will be in the next 5 years, let's say, but it's also about the geopolitical uncertainty. And this is a very interesting read from actually the next speaker, that this was unintended publicity. But it's more about the fact, how do we deal with what is happening outside today? How can we try and make what is happening around us a sort of learning, a sort of better world? How can we make ourselves feel better about ourselves, let's say, let's put it like this. And the nice thing that I want to note here, apart from the read in itself that it's very interesting, is the fact that there is a way to engineer the technology for peace, right? Because again, this is about how technology does not live on itself. It's actually interacting with what is around us. And specific principles like transparency, inclusiveness, and adaptability, but also public oversight, this will not just benefit to translate technology from military to peaceful technology, but it's also by definition a good engineering practices. So I just encourage people to think about this and to remember what we learn and how what we learn is actually relevant today, even seeing how gray, let's say, things can feel. And what can I do as an early career chemical engineer? And here my idea is that you can be working in traditional chemical engineering fields like wastewater or oil and gas or automotive. You can be working in novel chemical engineering fields like artificial intelligence, virtual reality, healthcare as well. The point is, sometimes when we are working in something more traditional, when there is a lot of background, it's much harder to think that we have something to say. While it is a bit easier when the path is still being formed. So, for example, when there is not, when things are still not defined, it feels a bit easier to be able to be part of that definition. But I just want to remind everyone that these two sections are not as isolated, that are actually intertwined, and especially the novel is not here to replace the old. It has to build on the old. So we, the younger, let's say, generation, but not just us, we are the drivers of this transition. And as we can express our opinion in the novel fields where the path is still to be formed, we should feel free to express our opinions also in a more traditional background, even if sometimes things like imposter syndrome can be a bit annoying, let's say. And another thing that we can do today, that each and every one of us can do today, especially as early career, is about thinking of equality, diversity, inclusion, and belonging in the workplace. Because wherever you work, it's always about giving different tools to different people, because everyone needs different tools to thrive. It's about thinking about different stories and different perspectives and accounting for them, right? It's allowing everyone to do everything, job-wise, of course, and especially doing this in a respectful manner, and finally being valued as a person. And this can be done only by valuing others as well and feeling connected with others. So this is something we can have a direct impact today anywhere. And in the end, we are all just people, right? And it seems very trivial, but I feel like sometimes people forget. And one of the ways is just to remember how we wanted to be treated when we were students, when we were postdocs, when we were like interns, for example, and treat people in the same way. And I think I am running slightly over time. I will be very quick. It's if you're like me and it feels sometimes overwhelming to think about all of this decisions to be taken, there is a very short checklist from this book, which can be nice to use, which consists of 3 steps, and the first one is it legal? So if you're unsure of what to do, this is the first question to ask, and then of course you can ask if it will have repercussions on other people as well, in short term and in the long term, and finally how it will make you feel about yourself. This is, let's say, it's just to make the choice easier. And finally, we're not alone. We work with other people, and every effort is better than no effort. And if you're an early career engineer, if you're interested in all of this, I couldn't resist to do a little bit of self-promotion. I promise it will take only a minute. Please message me or follow us on LinkedIn. Become part of the early career chemical engineering section. We are a section that is currently all over Europe, and we have more than 70 general members, and we do a lot of things. And one of the things, apart from working with the Working Party on Education, which is amazing, is also that we are starting with a new initiative which is targeted explicitly on the ADI and B awareness. And with this, I thank you very much for your attention. I thank you again for the invite, and I would be very happy to take any questions.
Thank you so much for this insightful talk. It was really wonderful. We still have no questions in the Q&A, but Alessandro, you have.
Yeah, no, just since Kseniya, you highlighted the importance of dealing with people, which is very much true. I think Just a question is, how do you see this, this aspect of handling people? What can we do, and what can be done in the university in lectures and courses to bring more awareness about this people aspect, which is probably not today a priority in the lectures, of course, others being, but the people topic is, I think, very important, and maybe there's ideas there that could help lectures to highlight and bring more awareness.
Thank you so much for this question, actually, Alessandro. So apart from the lecture side, from the point of view of collaboration, I have one thing, and only one thing, that can definitely help everyone, which is transparency. It's respect, yes, it's being kind to people, it's remembering that we're talking about it with other people, but it's also about transparency. All of us have opinions, all of us have, let's say, objectives, and it is important, especially when you're talking to someone who works for you, in my opinion, from someone who is still working for other people. There should be transparency from both sides of what is next, of why we are working on something together, on what should be done and how it should be done. And of course, there are ways of saying things, and everything can be said nicely, okay? And the other thing is feedback. Feedback is extremely important, and I think there is not enough. This is also regarding lectures. I think I discovered what positive feedback is coming to UK. Okay, I think some countries just don't have this. And again, positive feedback is not about, oh, you did a great job. No, it's simply about recognizing what has been done well, what has been done, what could have been done better. That's it. And it would be so easy in my mind, again, just to say that. It's not, I mean, yes, of course, I would like to say it's not that hard. Sometimes it's incredibly hard, but it comes from both sides. We should be able to communicate these things without fear of losing the job, without fear of repercussion, without fear of losing opportunities. This is from the side of the student. And from the side of the lecturer, we should be able to say this without being undermined. My authority should not depend on the fact that, I'm being nice to someone. I hope this makes sense.
It
Yeah,
absolutely
a lot.
does. Yes. Actually, we are a little bit behind of time, so I think we should go on. And we have the first long question from Moises in the Q&A, but I think it's also related to how to solve it in education. And now we are moving to the educator focus, I would say. So how to teach ethics. Actually, during your talk, I was thinking about that probably you learned a lot of ethics during your undergrad studies, just the awareness was missing that you did that, because you have so strong opinions on this. But let's go further. So the next speaker is Børsen, and then we are going to talk about how to teach ethics in chemical engineering education. So the floor is yours.
Thank you very much. Can you see my screen, and can you hear me?
Yes, both, yes.
Okay, so I just minimize the window so that I do not see you. So please interrupt if there's anything you don't understand, or you need me to explain in another way. But anyway, my name is Børsen, and thank you very much for inviting me to present this educator/research perspective. What I will do is today is partly to introduce some of the work I already done, and you saw a very tiny glimpse of that in the previous presentation. But I will explain a little about that. Basically, I will focus on or explain the nexus between chemical engineering, ethics, and engineering ethics education, which are two areas that I consider my research area. And then I will go into new territory, new grounds, because I'm also testing some of my contemporary work that focuses on the temporal aspect of chemical engineering education. So I'm interested in also receiving your feedback on how we should manage this temporal aspect, because on the one hand, we have also heard in Alessando's first presentation, it's about the process. We need to make good decisions, and we do that in the moment. But we also know that our collective work as chemical engineers have future impact in the long run, and there are many good examples of how we contribute to global health, but there are also other examples in terms of pollution that are maybe not so fortunate, but they are very much out in the future. These implications, they are uncertain. So how do we actually bridge these two, the now and the decisions in the now, and some of the future implications? And I will do that by somehow presenting and reflecting a bit on what is the role of near future and career development or career reflections among chemical engineering students. And then I will have to say that I'm from Aalborg University, and that's a problem-based learning university. So I will also introduce the idea of problem-based learning and how that can underpin ethics education in chemical engineering. So I hope you are up for that discussion here. About myself, I have been moving back and forth the STEM disciplines and the social science and humanities. I did that when I did my degree at university in chemistry and in philosophy. I worked at the Pharmaceutical University, at the Niels Bohr Institute, but also at the humanities. So I have kind of pinned it back and forth. But my interest is in the intersection between engineering and ethics, where engineering somehow reflects more broader the STEM disciplines, and ethics somehow reflect more broader issues within the social sciences and the humanities. Recently, I have been so honored to join two very special organizations that address this. One is the European Society for Engineering Education's Special Interest Group on Engineering Ethics Education. So we actually have now a professional body. We have a community where we discuss research based how to actually do engineering ethics education in different disciplines, chemical engineering, but also other areas in engineering, other disciplines we discuss. So it's a community. I would say I think we are around 100 who are somehow doing research in that area. So it's really a growing and wonderful community. So I invite you all to join us. Then the other body is that I was recently elected to the board of the Working Party in Ethics in Chemistry at the European Chemical Society. So I think that the area is really maturing and developing. and that's I'm really happy for that, because it also boosts my own works. Yeah. Then some years ago in 2021, the book Ethics in Chemistry was published. It was a book I co-edited with the historian of chemistry, Joachim Schumer. At that time, or I think he still is, the editor-in-chief of the journal, Hyle, on the history and philosophy of chemistry. And we did this book, Ethics in Chemistry, because we thought there was a lack of teaching material that specially focused on, or that could be used in teaching ethics in chemistry and chemical engineering. So what we did at that time was to ask different experts to write case studies where there were like ethical issues regarding chemical education, chemical engineering. I would rather say practice. So these are examples from practice that could be used in teaching ethics in chemical engineering and also in chemistry. The book is clustered, or the different case studies are clustered in different areas. We have a section on misuse. We have a section on unintended implications. We have a section on long-term cultural, societal, and environmental implications. So we distinguish here also timely between more immediate implications and long-term implications. And finally, we have a section on all the good examples and how we can prevent unethical behavior. We have one on the legislation, the REACH legislation, for example. We have one on codes of conduct and things like that, but we also have others. Then after that project, then I would like to mention this book on the Routledge International Handbook on Engineering Ethics Education, and this is a book that came from this special interest group in engineering ethics education, where we wanted to collect what do we actually know about engineering ethics education at the moment. So it was issued just around in 2025, just around the turn of the year between 24 and 2025. This book is then split up in 6 themes. One, kind of the foundational aspects, what is engineering ethics education, interdisciplinary contributions to that, disciplinary similarities and differences between chemical engineering, ethics teaching in that, and civil engineering, electronic and electric engineering, and also all these different disciplines. How do they differ, and what are the similar challenges these different disciplines have? Then we have a section on teaching methods, including the problem-based learning approach that I will present here, but also humanitarian engineering, case studies, discussions, Socratic dialogue. So there are many different teaching methods that you can apply. Then we have one on assessment. How should we assess ethics in chemical engineering? Maybe we should not use the same assessment approaches that we do in other areas. Maybe we should, but this is kind of the discussion there. And finally, we have a section on accreditation that we also already heard about. But the idea here is that it's actually really important to teach ethics in engineering education, because the type of challenges that we face, they are socio-technical, they are complex, and also that our decisions actually shape future society, shape the environment, and we shape the communities. So We are actually, as a colleague in Delft University, or in Twente now at the Amsterdam University, Peter Paul Fabik says that the most important ethical agents actually are the engineers, because they have such an important voice in shaping the future. Therefore, this power, if you like, really shapes our responsibility in engineering practice, whether it's individual responsibility or more organizational ones. But anyway, I would like to recommend this book also. Then let me very just briefly say what is chemical engineering ethics. And here I would like to make this distinction from literature between internal ethics and external ethics, or in another jargon, we also talk about microethics and microethics and macroethics, where the internal ethics regards decisions made, or responsible decision made within your proximity, in your discipline. So it's personal integrity, it's your professional responsibility, lab safety, things like that. And then we have the external and the ethics and the macroethics that has to do with what are the relations between chemical engineering and society, involving both sustainability and public safety. I do realize there's a gray zone, and maybe it's not really, maybe this is not the best dichotomy or categorization that we can choose now, because there is, of course, this gray area between the two. Of course, our discussions within or our approach within the internal ethics, that also has to do with that has implications for society also, of course. So maybe it's time that we have another dichotomy. So we have within engineering ethics education, there are some current challenges, and I think we heard a little bit about that. So students, they might learn the ethical principles, the codes of conduct, the case studies, maybe not the challenger case study, but something that might be more related to chemical engineering, but still the challenger case was also that. So they learn about these principles, codes of conduct, and cases that the teaching is actually focusing on, but how to translate that into concrete practice. That involves the uncertainty we heard about. There are also power relations. We are in hierarchical organizations, competing interests that we saw. So how to do that translation? Another maybe slightly different, but also related challenge has to do with emotions, because we often exclude emotions from ethics education in engineering, and maybe that's not what we should do. Maybe we should embrace the emotions, because they're crucial in shaping moral awareness, in judgment, and motivation for actually learning engineering ethics education. But of course, we need a reflected approach to emotions, and not just follow our kind of initial desire to do something. But maybe it's a good indicator that something is wrong if we react to it emotionally, and especially this is what we might learn from this, from like a philosophical direction called phenomenology, that what is actually what might be important is what we kind of perceive. So we have an emotional reaction. Okay, maybe we should follow and analyze that. Right. So instead of this micro and macro and internal and external ethics, maybe we should make another distinction. And here I would like to propose a distinction between engineering morality. That is kind of all the principles that are embedded into the codes of conduct, into ethical principles, but also into many of these iconoclastic or very not iconoclastic, but really the very famous insightful case studies that we have and that we presented in our book Ethics of Chemistry. So that's on one thing, and I really think this kind of basic knowledge that is really important, and the codes and the principles, they address both the practice of chemical engineering, but also how we relate to society. So their aspects here are kind of clustered together in one area. Then we have, on the other hand, the ethical engineering action, which is actually the ability to translate many of these principles into real-world situations, and also in concrete situations to manage dilemmas between different kind of ethical principles if you encounter that. So that I would like to suggest as another dichotomy that could also structure our discussions on how to include or how to teach ethics to chemical engineering. And then of course, we need to be mindful of the context. Yeah, just 2 seconds. Okay, there. Why does context matters? That's because
We don't hear you now.
You don't hear me
Now it's okay.
It's okay now.
No. Try to speak.
Yeah. Okay.
No, you are very silent.
You don't hear me now?
Now it seems to be okay. Try to speak.
Okay, I speak now.
No, it's appearing and disappearing. Maybe your
Okay.
mic.
Okay, maybe my mic. Okay, I will try another set. Okay, do you
Perfect.
hear me now?
Yes, it's perfect. Thank you.
Okay, good. Sorry for that. Well, now I need to kind of share my screen.
Yes.
Yeah. Okie dokie. Right, and I was here. Okay, sorry. Okay, I was talking about context in different domains. Why does that mean? And the reason why I highlight that is because there's difference between, for example, working in a developing and a developed country, for example. So we have different inequalities, different possibilities. We have different community-industry relations. And we know that ethical decisions are shaped by history, culture, and power dynamics. So the context is important. So we also need to think that into account. And I'm not sure that how we actually do it at the moment is really reflecting that. Because often we also heard about this integration model that we have it's integrated into technical courses with very general content. We have a limited time allocated to ethics teaching. We have this focus on the codes and the principles and the case studies. And we don't devote too much, or we don't speak about engineering ethics when it is about the decision-making skills. But that, I think, is really central. And I think that that problem-based learning might actually be one approach to actually move chemical engineering ethics education in a direction that respects context, that respect also move focus on the decision-making skills, because problem-based learning, that is like a pedagogical ideal that starts with problems, with open-ended problems that chemical engineers, chemical engineering students might actually encounter. And then the idea is that the students work in groups, and then they kind of qualify how can we actually address that kind of problem. So if we allocate or say a starting point might be an ethical dilemma or an ethical problem, then we build up like the collaborative discussions, and we discuss and then we kind of scaffold reflections and ethical dilemmas on that in that, and then it's project based, so students do projects. So we don't really need lecture based teaching to scaffold that. You do it in projects. We do it at Aalborg University, as I said. There, half of the semester is actually allocated to problem-based learning, to project work, and then in the other half we have the projects, and then where they work on these problems. Then another thing I would like to suggest that has to do with the temporal dimension of engineering ethics, and why not take that into account in the education. So first of all, we know that engineering decisions, they unfold over time. As I said in the beginning, we have some immediate safety issues, perhaps, that we need to address. And then we have long-term environmental and social impacts. But there is kind of a missing area there. And I think in the meantime, that has to do with the reflections for students' careers. So if they actually, I suggest that when we talk about engineering ethics education, also focus on how does that fit within the individual student's career choices. So we should imagine what kind of career can we have that can kind of bridge the gap between the different between what is happening immediately and what might be the long-term implications. So I would suggest that we include this kind of reasoning over time. So what we should focus on also, because we have many examples of dilemmas in the situation, and we have many examples of long-term issues and problems, but we don't have many good examples of what is happening in the near future. And I think that that is something where we should also focus on between, let's say, we can ask the students to reflect, where are you from 10 to 20 years from now? So then they should say, what kind of responsible careers can we actually undertake, and begin to think about that, so that you can actually have a career where you have the possibility of conducting ethical conduct. Yes. So, and I think that problem-based learning might be a good carrier there. If we use these near future scenarios as input for the problem-based cases, we assign, we think of what kind of professional roles, what stakeholders are involved in these cases. We embed some of these dilemmas that will arise through such a career, and also look at the technical that are related to technical problems. So what we are focusing on here is socio-technical careers. So I think that these ethical decisions should be bridged with professional identity and more long-time impact. I think that would be kind of a viable approach forward. So then, how do we then think of problem-based learning in practice? And I will very briefly stop now. I have only a few slides. So we have this kind of. So how can it actually happen in practice? And here I would like to make two suggestions. we have these humanitarian engineering projects where students, they actually work within a community. They sometimes even travel from their own country to another country to work on these development projects. Of course, we need to be a little bit mindful on maybe some colonial aspects of this travel from maybe from Denmark to another country, but still I think it's a good idea and promote collaboration to go and work with communities around the world. And the second issue where we or model where we can work with the engineering ethics in education is in industry internships. So you actually take some of the dilemmas arising during an internship, you go back to university, you have some reflection classes. How can we actually manage that? I think that would be another nice examples. Yeah. So and I think that will scaffold that the students can actually reflect on their future careers. So this leads me to the conclusion. So I suggest that, and I also extract some of these suggestions from the research discussions, namely that the ethics education in chemical engineering should develop ethical reasoning. Not only should we focus on learning the codes of conduct, the ethical principles, and the case studies, but we should also relate to concrete decision making in difficult situations, and that's both in the situation, but also extended temporary to also address some of the career choices. And I think if we make this bridge, then we can actually we can make an even bigger difference and make kind of the whole thing to be kind of more coherent. So I suggest that we use problem-based learning combined with this near future reasoning to prepare the responsible chemical engineers. So with these words, I would like to thank you for your attention and apologize for this short problem I had with my headset. So thank you very much for your attention.
Thank you very much. Very interesting, and already going into the methodology part. Maybe we have time for a short question from the panelists if you have anything, or we can go further if nothing right now, because we have a lot of questions regarding how to put it in the curriculum and individual course or not, but I think it would be best to reflect to that one at the very end of the session, just after Jan's talk. Maybe just go on with Jan's talk. So the floor is yours, Jan.
Okay, thanks a lot. Thanks also for the previous speakers. I have maybe not much to add, but maybe exactly that missing stone that people are asking for, and that is like, what does it mean concretely for education? I fully agree with Tom's conclusion that what we are actually trying to do here is not just, educating students for doing a tick box exercise, saying, yes, I know this guideline and that code of conduct and I comply to it, but that we realize that many of these, especially macro ethical, as we have learned, problems require communication, a deliberative approach, figuring out what are the stakes and values and so on, which is far beyond just, looking at codes of conduct and fulfilling one's duty. So what I'm going to talk about is ethics by design in chemical research and innovation, and what skills and competences are needed then in practice for a sustainable transition. Just quickly, because this talk is not much about me, but of course it's useful for you to know why I say the things that I say and what is my background. I am a chemist by training, but during my PhD I realized I'd rather talk about chemistry than doing chemistry. I studied applied ethics. I was very much interested in research ethics, technology ethics, science ethics, and combined these two in my first job in the field of technology assessment, which in the German, but also Dutch and Danish understanding especially has a lot to do with ethical dimensions of technologies. So I understand that as a field that tries to understand what impact technology has on people, on society, on environment, and that basic understanding that the values and stakes in human technology interaction can always be somehow controlled, facilitated, yeah, maybe even designed for in innovation processes. So what we need for this is discourses going on about the whys and hows of technologies. For this, we will always need participatory and interdisciplinary approaches to technological design and governance. So having said that, I quickly like to show you the research project I'm currently working on, because this shapes a lot of what I'm going to say today. It's called RE for Green, Research Ethics and Integrity for Research and Innovation Supporting the Green Transition. It is a Horizon Europe coordination and support action. So if you will, the European Commission is asking us, how can we better account for environmental and climate ethical considerations in research and innovation endeavors? So for example, someone is applying for funding in the Horizon Europe line. We want these researchers to present how they understand ethical dimensions of their work and how to tackle these. So after all, this project also wants to deliver or provide training materials for all the stakeholders involved. That means researchers, innovators, but also those who evaluate research proposals and have to make a judgment on whether ethical dimensions have adequately been addressed in there. We chose a participatory approach, which is important to point out from my perspective, at least. We are not doing some intellectual academic work here. We are trying to understand research and innovation cultures, how people do apply codes of conduct, methodologies for deliberative discourses, and what is their perspective in making the daily business of their job, so to say, feasible. The goal is then to contribute that orientational knowledge on the environmental and climate ethical dimensions of research and innovation, not only for technology development, I have to say, of course, this also concerns policy research, for example, economic research, let's say develop of business models, but even basic research. So in this project, we face these dilemmas that the three speakers before me have pointed out. It's perceived as a, let's say, bureaucratic act of saying, okay, I have to write this page in my proposal on ethical implications, but I'm not an expert on that. I need a lot of manpower and I can't really do it. So what is really necessary as an orientation for people to do this effectively within, let's say, the range of their core expertise? So one main conclusion is that we need what I would call normative literacy. And that is understanding ethical dimensions, of course, with some help, let's say, and then translating this into actual design to get that step done from an aspiration. I mean, admitting ethical dimensions are somehow important, but really make it something like a design requirement, taking it to the benches, to the labs, to the field, let's say, and really translate this orientational knowledge into particular design. So when I say ethics by design, what is meant by it? I find two basic understandings in the literature. So the community is not decided on like what does it actually refer to. There is one big group of people who says this is related from the perspective of research integrity to the research process itself. So then ethics would mean we talk about ethical norms in research, good scientific practice, code of conduct, and then how can I design a research project or approach so that all these, let's say, requirements are met. So what is to be designed is the actual research project. So and how researchers planning their research in such a way that methodological choices and their oversight pass ethical evaluation. So that we can say, for example, guidelines of research with or on humans or on animals are met, or that environmental impact has been assessed, and all these kind of things. So an example here, let's say a chemical reactor upscaling for industrial application. I mean, this is, I'm not saying anything really new here. I guess you are very familiar with this. That in such a project, we would check, because of an exposure of researchers to critical components in an upscaled reactor, safety measures have to be taken. So how? One approach would be safety equipment, but another maybe more novel idea would be we can do a modeling first, create a digital twin with the methods that we have nowadays, and model the performance to just exclude worst case scenarios. So if I have a research project and I can see that the team is aware of, let's say, maintaining safety with such a measure because they have realized that this is a very important stake here during the research process, I guess such a project has a higher chance of really getting funded. Now there is another understanding of ethics by design, and I call that the perspective of responsible research and innovation. Others would say that's not ethics by design, we call this designing for values. But let's take it for now that also this is the understanding of ethics by design, actually. So ethics as a placeholder, in this case, for all kinds of stakes and ethical values. For example, safety, privacy, justice, autonomy, sustainability, I would put here too, or integrity. What is to be designed is the outcome of the research and innovation project. Maybe a technology, a device, or a process, an industrial or economic one, a policy advice, a business model, or maybe even something like a risk assessment procedure as the output of the research process. And the task is to design it for the protection or endorsement of certain values. So researchers and innovators then, as designers, would make informed and value-sensitive decisions on the path to be taken. Now I have a very simple example, but it's not chemistry related, but I find this one really telling and illustrative. Imagine someone is developing service robots for hospitals. Let's say one that comes to the patient's bed and delivers medication, with the idea that then the caretaking personnel has time for a more important task than just handing out medication. So this can be done by a robot. This is a real project, by the way. And then we find that these robots are rejected. The interaction with patients is a little bit difficult. Patients complain a lot or even are afraid of these robots. So then we find out that they really wish to be in charge of the interaction. When this robot is standing, they're really waiting that the patients take the pills out of these drawers with the sensors. They overpower the autonomy of the patient. So we want self-determination in this process. So what could be done? Developers design controllability into the robots, for example, by adding a very visible off button on the front. The interesting thing, by the way, is that we found this button is never used, but just by having it, we support this value of self-determination, and the people feel taken serious in their value commitment here. So this is a very simple, let's say, design task. Now I give you a chemical example, but I also want to get away from these technology ones and show you the development of a chemistry-related business model, and that is chemical leasing. So imagine a company is producing metal parts, and after the production, there's some kind of greasy, fatty film on these metal parts that has to be cleaned. So now in the traditional model, the metal firm would buy solvent from a solvent producer. And the solvent producer is actually interested in the solvent user not using the solvent efficiently. If they spill a lot, the solvent supplier would sell more. So they're interested in an increase of consumption, whereas the buyer would be interested in a decrease of consumption. So now this is not very sustainable. There could be spills, there could be pollution. So a reduction of solvent would, let's say, be the best way to go in terms of sustainability. So what can we do? We make a business model. We design this process in a way that all stakeholders pull in the same direction. For example, the solvent producer is not selling solvent, but is selling cleaning service. So if the metal firm pays the solvent producer by cleaned metal parts and not by how much solvent they are buying, then suddenly, just by the change of this business model, by the change of the interaction, both want to decrease the consumption, because for the solvent producer, it is actually more effective to decrease the consumption as well. And once both pull in the same direction, we know something will change. So we design this business interaction for sustainability. by a simple rearrangement of the business model. So you get where this is going. Like ethics by design means I identify by some means what is the stakes here and for whom, and how can I take measures as a designer in the really widest sense, a researcher, an innovator, a scientist, an engineer. How can I make a decision so that a particular value is supported? How we come to the value, I will get to in a minute. First, I want to say something about the preconditions for this process. So well known are already safety by design, privacy by design, especially in the context now of digital technologies. But if we think it further, why not put other values there for that, like X by design formula, autonomy by design, justice by design, sustainability by design. And since I'm talking about environmental and climate ethical considerations in research, eco by design. These are sometimes at least genuinely ethical topics and really hard to assess. There is no indicator for justice. Yet it is clear that when I design a new process that involves, for example, supply chain changes or a rare earth metal that is mined in areas where it is not clear if workers are protected by law in their integrity, if this becomes a question of our design choices for a process, it's not clear how can we justify this when being questioned. Usually, especially in corporate context, we want KPIs, for example. We want some indicator, something measurable. And for questions of justice, environmental justice, resilience, and so on, they are not always clear or not clear at all. So what we need is more knowledge. And my claim is this knowledge is available and viable today. Now comes the only, let's say, theoretical background graph I want to show you. Maybe you have heard of the so-called Collingridge dilemma, who claimed in the beginning of the 1980s that at an early stage of a design process, the flexibility is still very high. We can take this path or this path. We can choose this component or that one. And in each case, we would decide which is the best one. We are still flexible, but we lack knowledge about the actual impacts. Only when the design hardened, when something is marketed, when a prototype has been produced or maybe even then mass produced and put on the market, then we know about the impacts and how people would use something or what is the environmental footprint of something, but we can no longer change anything in the design, which is the dilemma. So the observation is that this changed in the 40 years since this has been published by Collingridge, saying we have much more knowledge of impacts nowadays. We know very well the connection between certain characteristics of a technology or of a process or of a policy design and its implications for the world. So here is a range, just quickly here, an overview of disciplines, starting on the bottom left, really with something theoretical like philosophy of technology, sociology of technology, or techno-anthropology, telling us about post-normal science, about the social construction of technology. Like there's a lot of insights on the relationship between technological progress and societies, or maybe a societal progress and technologies. So with this, we inform really more applied or methodological transdisciplines, such as technology assessment. That again produces insights that are very much related to the daily practice and method of the practitioners, like responsible research and innovation, combining knowledge about innovation cultures and decision-making with these, let's say, contents that are to be used, like applied ethical knowledge, ethical, legal, and social implications research. Even to a degree, and that's the top right then, where we say there are concrete tools for this. Value-sensitive design, user-centered design, design thinking, or concrete tools that you can use, like societal readiness tools or ethical impact assessment, where you can, without having to go back to the bottom left, you could really just use the tools in your daily practice in regard of, let's say, the knowledge foundations of it. So that's my claim. The knowledge is out there, and we can integrate this into courses. Tom, is it okay if you ask the question at the end of my talk?
Yes, of course.
Then I come back to this one. So another precondition I would say is that communication channels are open. The only way to make sense of the values and stakes is by bringing the people together who can express their stakes and values at hand. We don't want engineers or scientists or researchers to make these decisions. That would be very technocratic. The only way here is really to team up and to say, okay, I try to understand what is the stakes for people, and then need to find a way to navigate this. We need co-creation opportunities where we can work in trans and interdisciplinary manners, but maybe even adisciplinary, by which I mean people are involved that are not defined by their discipline, but maybe more like by their, let's say, impact profile. So researchers then would need normative literacy, which just means actually to be open-minded for the idea that their work has value implications. And the task at hand is to understand this. So to get one step closer to this, I want to talk a bit about value co-creation here. What do I mean by this? Like everyone involved in the development of processes or technologies has certain value ascriptions. Engineers create function. In economics, the value would be something like the price or the profitability. In psychology, on the other hand, like what is value can be measured by some definition of satisfaction of individuals. And on the collective level, on the societal level, that would be something like integrity. The ethical understanding of value is what is good or what is right. In all of these, actually, I can also represent the environment, which I did not put extra here because that would get us into the discussion on does environment have values or interests? But we can represent the environment here by any means. We know of conflicts, of course, here. We can create the best function, but if, let's say, the party that is funding the engineering approach or the innovation project says that's too expensive, then we have a clear tension here. These are, let's say, discourses that usually people working in corporate innovation contexts are very familiar with. But the other values like societal integrity, psychological satisfaction, or ethical values, we often don't have these channels yet. So what is actually required in the sense of normative literacy is to be able to listen to those expressing these. My claim is if we manage to co-create value, that would be the actual sustainability. Also here, just my attempt to present an example for you. If we try to eliminate toxic chemicals from an industrial process, but the price for that would be that I would need a material that can only be mined in an area where worker rights are not respected, then can it be the task of those developing the process to find alternatives, or at least to raise the voice and say this is a problem we discovered here in the context of our work, so we know about these stakes. So what are the tools actually to navigate value conflicts? This might be even more important than eliciting the stakes here. For the actual role of ethics, that is sometimes well regarded as a very either complicated topic because people are not so familiar with it, thinking of, let's say, moral philosophy and ethical theory, or it is regarded as a, let's say, non-scientific topic. It's kind of random. It has to do with opinions and views and so on. Both, I don't agree. What we talk about here is much more, let's say, simple, the assessment of ethical questions, and a moral compass that we all have by growing up in a society is completely sufficient for that. It is also not random because it can be very much systematized. But the most telling image I can present to you is this one, that many people believe that ethics is a lens, that when we have some kind of dilemma or problem or challenge, we apply the lens and it is focusing on the right solution. Like we do ethics and then we know what to do. unfortunately, this is almost never the case, but that shouldn't worry us, because the much better image would be ethics as a prism, where we say we use it to, well, refract the challenge or the dilemma. So we can say, if you have a particular value stance, a specific reasoning method, you end up on a kind of spectrum of views. But once I know your position on the spectrum and I understand my position and how I get there, then we are enabled to start the actual conversation. And I think this is the main idea of ethics here, not as a solution provider, but as an enabler, to say, okay, I understand where people start from and where they end up. And then the discourse around it becomes much more rational, because I can question premises and not just brush it off the table saying, yeah, that's just your opinion. So in times of, well, in current times, you know what I mean, it is very important to rationalize discourses and understanding how people come to their statements and understand the difference between an opinion and an argument. So as a promoter in that sense, saying the best way to integrate ethical domains into research and innovation work, as envisioned by that framework of responsible research and innovation, is, of course, you do a good job and you help others to do a good job. That might be the micro-ethical domain, the internal responsibility of engineers. We also need to understand and always, of course, check thoroughly facts and values. And we have separate methods to do so. One, let's say, a more rigorous scientific one, the other one, a deliberative discourse approach. Don't be afraid of ethics. It's not moral philosophy. It's just using your moral compass. And that means mostly talk and listen, and of course, be constructive. Make the relation. There could be a whole other, let's say, half an hour of or even more of this webinar to say, okay, what is the communication task here? I didn't prepare a slide for this, but I find it very important. An image you might want to check from Robert Pielke, who calls it the honest broker. We don't want engineers or scientists to communicate just the facts about their work that many people cannot understand, even if they are not educated in the field. But we want engineers who can, in front of a panel, say, here's the options. And here they are related to the values that you are expressing. But we also get the conversation going about these value expressions. Maybe someone missed something. Maybe a commitment, for example, for profitability has to be revised, so we check sustainability instead. So if engineers have this, if they are enabled or empowered to stir these discourses, I believe this is the most sustainable way of doing engineering and science and research and innovation. So that is my main message. Thank you for listening.
Thank you so much. Oh, you talked about a lot of things, and I think that before I asked Tom about his question, just could you please, all of you, comment on the questions we received in the chat, which is about how to teach ethics, either in individual course or in integrated method, in communication. Moses described his experience with integrating it in a final year project, and it was a problem in the sense that how to evaluate whether the students worked on the ethical aspect or not. And also, I know that you have experience in ethical individual courses. Could you please elaborate a little bit, all of you, all the panelists, on how to teach it? So it's important, we understand, but how to embed it in the chemical engineering curriculum? Jan, maybe start.
Yes, I can share a bit of experience, and actually maybe in the program the title of my talk suggested that I would do that already. In 2018 I compiled a course, Good Chemistry, for the European Chemical Society, and at that time there was this naive belief that, I mean, first, finding at many universities there is nobody feeling competent in teaching this. there was clearly the call or the need for some orientation, like what is the content of such a course? So this online course was well received mostly by instructors saying, here is some content that is like a benchmark and I can build on this and use it. Now, 8 years later, I must say that the course really needs a revision, because what we underestimated is that by teaching this in a kind of lecture style with a few exercises, it would change anything in the students' behavior. But unfortunately, empirical studies show it doesn't. Now, if we have a whole course on research integrity, the susceptibility for fraud, for faking data, for example, is the same. It doesn't change much. But what does change, and that was also feedback of students who said, hearing about this, ethics by design idea, about saying I'm part of a process where I have some authority to say, if we do this or that, it would have this or that implications, and building on that. But that means such a course cannot be a lecture. It must be what Tom says, a problem-based learning course, maybe something integrated with, or no, provided for students already experienced with actual research at the master level or PhD level. For bachelor students, having mostly theoretical classes and not so much lab experience, it's harder to understand what it means to actually take the knowledge and make a choice, or take the insights and get into a discussion with the PI or with someone, with the superior, saying, okay, I have doubts about a certain decision, can't we do it differently? But the actual competences are only shaped when they can be applied in such a way, where you have someone saying, okay, here's my choice, and why would you disagree, and what is the better choice? So there was one doubt expressed also in the chat, saying, well, what difference does it make? The students believe because they don't know what to do, then it's kind of like random, they have to do it. I think it's all about engagement. So if an instructor says, here's a case, and this case is something you are concerned about, because when you started studying, this was exactly what was your motivation, do something good for society or change the world, at least understand the world. And then if the cases or the problems discussed in the context are really engaging and students feel like, yeah, actually, that's correct. I mean, that's my experience, then the students will really take it very seriously and say, okay, I see where I understand things better. And I mean, that's probably true for all kinds of education activities. Don't lose the students by doing something boring.
Is it something, Tom, you would agree with this problem-based approach?
Yes, the very short answer, but let me expand a little bit, because on the one hand, there is a need to scaffold some of these activities, to introduce some of the tools you can actually use in a concrete situation. And when I talk about problem-based learning, it could just as well be during an internship. You do an internship and then you do the internship report. You encounter some issues and then you bring in some of these tools that then Jan was mentioning in his slide after following the discussion on the Collingridge dilemma. So I think these tools can be delivered in different ways. It can be during a course. It can be on kind of these micro courses, online courses that the one Jan developed also. It can also be like a session integrated in different core courses. But I think there should be some kind of scaffolding, not that much, but a little bit, and preferably integrated in the remaining content. Then it depends, of course, on the project and the problems you are working with, to what extent this is interesting and whether it can be interesting. But I think if there is kind of a feeling that this is important, and we get the support as we did today, both from the industry, from the student bodies, from our peers, but of course it's a collaborative journey that we collaborate on developing these tools. So it's not that, okay, Jan comes here, use these tools, or I come and just deliver these tools. I think some kind of negotiation where we actually see what formats could be useful, and then I think the assessment of also these teaching initiatives could be very useful. And there are now, I mean, the European Society for Engineering Education has now opened up a practice journal, so you can actually publish your didactic experiments with these teaching activities. And I think we should use that also as university teachers to get merit for what we actually do. I don't know how much it counts, but at least here's the possibility of developing and sharing our experiences and our knowledge. So basically, yes, I do agree, and I think it's a very important and good question that is difficult to actually, do something about in a more practical setting.
Thank you. Actually, I'm sharing the QR code for a survey which we put together as a working part of education, just to collect your experience, all of the audience, and you can also share with anyone else on the experiences, what you gained during being a student in chemical engineering or teacher or working at industry, whatever, ethics education, but not just the way, but also the outcomes and the expectations, because what I think it's much, much deeper than we typically think about that. So I would be very grateful if you could just fill this questionnaire and leave your feedbacks, and also a collection of methodologies if you have something in your mind. And meanwhile, just coming back to this assessment, which was really a very interesting question, which was mentioned several times, is that actually how to assess all these kind of things. And this is also a question related to what appeared in the chat. So, well, yes, assessment is a critical question if we embed it in the curriculum in any way. Yes, please, Tom.
Yeah. I mean, what we have found is kind of working best at the moment is like oral examination and oral assessment of these skills, because where you sit and talk, okay, why did you do that? What were the justifications? How did it work? Did it turn out as you expected? I mean, it's you can also, of course, do inline reflection papers, but now with AI and this, you can ask the language model to kind of to prepare these reports. So at the moment, our best bit is oral examination. It can even be group examinations where you're discussing your experiences, or what might be actually a good approach to this and that problem, and even how to do an ethical case analysis. Discuss it, present it, and discuss it. That's our best bit now.
Alessando?
Yeah, I think if we look at the case of the mentioned by Moses of the project at the end of, and that is, let's say, one of the key opportunities to build these skills and also assessment. In that project, I think we should, again, because it's a lot about the process, and just as Tom was saying, how did you get there? And so there should probably be a lot of checkpoints. So it's not only about the final report. Here it's kind of, and I know it's a challenge again for lecturers to do that, but after 2 weeks, after 4 weeks, these checkpoints to see how is it building up, how did you actually target, did you address all of these issues? I mean, if you look about the discipline of project management, there's a lot of practices that are there. I mean, there's risk management, stakeholder management, requirements management, and each of them being specifically developed in certain 5 phases of the development of a project. So, a kind of checkpoint approach maybe can help to build up that assessment about, how we are addressing all the issues and how we are addressing all these issues throughout the project.
Yes, Jan?
Yes, I have the feeling you two talked about a different assessment range here now. I believe, Edith, your question was related to assessing the effectiveness of educational approaches, right? And Tom replied in that line, and Alessandro talked about assessments typical done, let's say, in an innovation context. Like, how do I know my path forward is the good one, my technology or my process is a good one? I mean, both are very important questions. For the first one, I would like to add an experience, or like what I do in the courses usually is at the very first class, I give them a scenario of a research project they can all understand, and ask them, like, how would you solve, or how do you make a decision for when having to choose between at least 2 or 3 or more options. And then they have very scientific replies saying, I would do something like positive and negative error rates, a chemometric, something like this. And then when after the course, I give them the same scenario again, and then I see a clear difference that they say, oh, to make a good choice here, I need to have a multi-stakeholder approach. I need to ask these and these stakeholders. And so their vision really broadened. So there are assessment methods to really track some kind of learning or some difference qualitatively. For the other one, the assessment projects or assessment approaches that Alessandro mentioned, I think this is also really important to see that every engineer comes with a set of assessments they have trained, but that most ethical assessments fall outside this range. And instead of saying, here's another assessment for you to do, it's usually not very effective because people say, I don't want to. I spent so much time on other things. I cannot do this. I need more manpower, more competences, and so on. But turning it around, and I believe we are on this way, saying we pick researchers, engineers, innovators, scientists up where they are, say like, okay, you tell me what you are doing, and then kind of making a connection to the values that are probably at stake, and say, you already understood some of these, and here is some learning, some others that were not on your agenda yet. And then make this comparison to empower them to say next time in an innovation team meeting or research project meeting or in writing an application, saying, now I'm aware of this ethical problem and here's maybe a way out of this. I use value sensitive engineering. I use an open innovation method and so on. So and I think this is the best empowerment to say it's not about learning another form of assessment or having to study something, but to say, okay, the most important thing is communicate what you are doing. And here's the connection to the stakes. And then this assessment also becomes much easier.
Learning the vocabulary is also important, and just being aware that we are using all these aspects and skills, because yes, I think we do a lot. Kseniya, please.
Yes, I just wanted to add very quickly on this part of assessment and teaching, because while I in principle agree with everyone, I think it's not just about making the teaching interesting, but it's also relatable, because what is important to a student of the 5th year is not the same thing that is important for someone who just started university. And sometimes I feel like we forget that, and because it's very easy to forget. Because whoever finishes, whoever is in 5th year, they have a better understanding of the profession as a general. So they have a better understanding of what kind of impact we can have by definition. While when you're in the 1st year and you're studying maths or physics or like basic chemistry, it's really hard to connect that to real cases. So and it's also about this level of how relatable is what we learn to what we do and what we experience in everyday's life. And while I really like the ethics by design, because fair point, we might avoid so many problems by thinking in advance about all of this. But then how do you, I have no idea how to assess this, I'm honest. But at the same time, I feel like sometimes it's not about giving a solution, because a lot of engineering, a lot of assessment in engineering is about providing an answer. Maybe in this case, it's not that much about having an answer of what is correct, what is not correct. It's more about thinking, or like having an idea of what are the things we're supposed to think about, let's say. So it's not just I would make this choice because this is like my line of thought. It's more, oh, I'm building, I don't know, something, a plant. What do I need to consider in terms of environment, in terms of local population, in terms of cost, in terms of everything? And that is already a much more useful experience, because it's also about uncertainty, which we're not, this is what Alessandro was saying, we're not used to to being not certain of something. We always have numbers, right? So again, this is just a point of view, and I wanted to say something else, but I forgot, so I guess it's up to Tom.
Yes, Tom.
Yeah. I don't see this very strong controversy between what Alessandro said and what I said regarding the assessment. Actually, I think many of these the formative assessment, you can call it that, in a project that evolves, I think would be easily applicable also in an educational setting. I mean, you have to defend the process you are working. And since there's not necessarily right outcomes in engineering ethics education or addressing these dilemmas, there are certainly some approaches that we would say are wrong or unethical. But there can be many different choices being made over during a project that you somehow need to defend. And of course, you have to balance. And you also saw that on your slide, Jan, that there are economic factors, there are design factors, there are right and wrong, there are satisfaction, I mean, related to all these different disciplines. So I think actually taking inspiration from project management and how they assess the projects, because I basically see also engineering, chemistry, chemical education as basically projects also that you somehow need to assess. So I think we can learn from project management and their focus on process assessment, and I think that aligns with the idea of formative assessment.
If I may say something, I mean, I liked Tom's remark that if we want to assess it, then we cannot just let students write an exam. I mean, it's really about, I think, a discursive performance, really. So ending a course on that with something like maybe a role play, maybe like a kind of debate club style controversy, because this really shows then how much students are able to understand arguments, transform them in their minds, and then speak them out, and so on. This is not, we have to be a bit careful with this, because an introverted person might not speak that much, which does not mean that they didn't understand the matter or perform poorly. But let's say with some adaptations and refinements, I think it really needs a performative assessment and not let's say asking knowledge questions.
Yeah, that also brings to me back what Kseniya was saying, that to give the confidence of the graduates that they have opinions and they have knowledge on this, and they can just articulate, and that they can take responsibility because they are equipped. Because if we ask them to defend their opinion and explain those opinion, and there is not always a good answer, that's also a way of teaching competencies, I would say, important and essential competencies for the later career. But I think we are just finishing, and I want to conclude and close this session because we are just running out of time. And it was really an exciting session, and I thank you so much for being here and being so active. And I'm sure that we would be able to discuss it 2 more hours, but unfortunately our time is over. So thank you so much for the presentations, also for the EFCE for organizing this, and all the audience who spend their times here. And the session will be available online sooner or later. So thank you so much.